Okay, we are live. We are live. All right, we are live. Okay, so sorry about that. That's now at the moment. So sorry. So let's go straight to today's webinar, everyone. Let's go straight to today's webinar. So anchoring today's webinar is what is Dr. Emmanuel Ogedengbe, right? So he's the founding director of the Center for Renewable Energy and the Power Utilization at the University of Lagos. He lectures both undergraduate and postgraduate courses at Department of what? Mechanical Engineering, including MEG 510, that's viscous fluid theory, MEG 821, that's power plants, and MEG 822, that's renewable energy, amongst others. On research, he specializes in the use of experimental and numerical tools for renewable energy conversion and has published over 50 international articles in this field, including the following recent articles. The most recent one is we have Dr. Emmanuel alongside IB Seidu and M.A. Rosen in 2018, publishing the article Balancing Comfort and Energy Use for Sustainable Building, Thermal Comfort Modeling Using a Space Variant Mannequin, is an European Journal of Sustainable Development Research, Volume 2, Section 1. Yeah. So the second most recent article that Dr. Emmanuel co-authored, we have him alongside the person of O. Igbekoyi, A. Bakari, O.J. Alonge, M.B. Chita, and M.A. Rogzin, 2018 also, on the article titled Flexibility of Organic Thermoelectric Material for Photovoltaic Solar Energy Management and Conservation, the Open Fuels and Energy Science Journal. So there are a lot of articles that he had published, the number 50 and still counting by God's grace and still counting. And is one person that speak highly of international publication. He is one person that speak highly of international publication. And he has now what bring this international publication, he has bring it into Nigeria itself to localize it and ensure that what our published work don't just remain just published, but rather they can move from research and become what reality. And that's what went on to what bet the smart conference and even betting this particular news series, which is what energy management. And to take us for today, he'll be discussing the topic EnerghxPlus, thermal comfort analysis, and net zero energy management made easy. So I'm going to repeat it again. EnerghxPlus, thermal comfort analysis, and net zero energy management made easy, right? So I'm sure we all have a lot of questions in our heart already because the word EnerghxPlus might be strange or might be new to some of us, but don't worry, during the course of this particular webinar, you'll get to know what EnerghxPlus is all about, and it's going to take us through a wonderful ride of knowledge. So I'll be handing over to you right now. Thank you for having us today, sir.
Oh, thank you very much, Odunayo, for that wonderful introduction. And good morning, everyone in Lagos, Nigeria, if you are joining from Nigeria. And good afternoon to you, and good morning to those that are from North America here, like myself, and our YouTube audience, whatever zone you have. Good morning or good afternoon. So thank you very much. Give me 1 minute to share my slide before I start. Okay, I think that's you can see my slide now. Yeah, so as the moderator has mentioned, the title before us this moment of the live webinar is EnerghxPlus Thermal Comfort Analysis and Zero Energy Management Made Easy. I would run through this short highlight of the presentation, starting with just talking a little bit about those that have uh, spoken to us in the last series. As the moderator has mentioned, I will touch a little bit on the energy management practice in the conventional terms, and the challenges with the tools I've been using for this energy management. Then I will briefly introduce what thermal comfort analysis is all about, as especially when we're talking about a building envelope, and then provide the sustainability issue that comes to the task of addressing what we call net zero energy management. And then I'll introduce the EnerghxPlus platform and the proposed strategy for better testing of the platform. So the last series that we just rounded up last week, actually we had 8 different speakers. As usual, I started uh, the the series. We just trying to introduce prospective authors in the upcoming conference to know how aesthetic abstract is being drafted, the format of that. That was how that started. And from there, we started asking different energy experts from Africa, from Europe, and from North America. So the crop of all the people that you see on the screen in the past 8 weeks has been all across the globe, which actually lend credence to the intent we have for SMART to really be a global avenue for academic discourse and research. So I'll go straight to the energy management practice conventionally because of our time. And I just, will talk about what this is in terms of the target that we have in mind. Now, keep in mind, the target is a building envelope. And when we're talking about building envelope, we're talking about just building where people, whether they live or whether they do their business, a place of shelter that is, protect them from the outside environment. So that's what we call a building envelope. So there are a lot of effort that is aimed at a systematic, periodic review of the historical utility data. That is the data, the energy data that the building envelope consumed over the years. There have been manual schedule of the equipment that have been used, whether in terms of the HVAC or all the appliances, and the fixed schedule of operations that is used, to control how these are being used. Most of the time, conventionally, you have to do what we call a walk-in audit. You have to walk in into the building envelope, whether it is the owner that feel he or she wants to do that by himself or herself, and then has to look at all these data and gather all this information, which most of the time so discouraging. And sometimes, if you don't have the knowledge, you just ignore about that. The only thing you do most of the time is just for you to complain. Oh, my hydro bill, for example, in North America, we call it hydro bill, or in Africa, my electricity, bill, what is this? Is it being estimated, or is it being assumed, or what the meter is reading? And you probably will not even know exactly how those information actually come to be computed. Another time, somebody might have knowledge and then has to go all the length to spend the time to be able to compute all the various things that contributed to all this. Over the years when I started in the industry of energy management. I have had the privilege of working through manually most of the people that I work with, I call client, and then you will see a typical commercial building in the city of Ottawa. You see over the years, these are the data of the historical consumption of natural gas that that supermarket uses, and then the electricity that was consumed. You can see that from March 2009, to that particular end of the time that you see even in that very chart. Sometimes you might want to take like 2 years, sometimes 1 year, but at least 12, 12 months is sometimes is okay. But if you take 2 years, you have more trend. So you need this trend to be able to understand what are the nature of the thermal demand, what are the nature of the electricity demand in terms of the building and the services, and how this has been distributed, across the building envelope, so that you'll be able to understand what you want to do. So as a service provider, then if you have an opportunity of linking all this information with the utility, that serves that very client, then you might be able to understand what to do, to manage this the energy that our client is using. And then if you move from one different type of building to the other, you have different scenarios. So you can see different type of building picture that you see here, from being an apartment, office, or whether it's a bungalow or it's a factory. The dynamics changes from the type of building and the type of behavioral practice that goes on in that particular building. So these are the conventional energy management practice that we should be very much familiar with. And later, when I had the privilege of moving my practice to University of Lagos, I've had the privilege to do a comprehensive energy audit of the University of Lagos, which I started when I was the director of the National Center for Energy Efficiency and Conservation before I left. Even though the project was not completed then, but there was huge data, like you can see for a single building that you see on this very huge data set that was harvested. Now, the problem is, what do you do with those data? Up to now, I cannot say exactly whether those data actually are being used in a proper way to provide a type of what is intended that that data will served, to provide. So now I want to talk about the challenges with the tools that we've been using that are very much available in the market. There are tons of energy management tools, but I just picked these three just to just illustrate something, about the conventional energy management tool that we've been using. Now, EnerghxPlus is very popular. Is deployed by the Department of Energy, United States. So it's more like the most accurate, standard energy management tools that any researcher that in the field must have possibly used. Now, the problem here is that these tools are being used by researchers, just as I've mentioned. And we are talking about a challenge that a home user, whether it's residential building envelope, or a commercial building envelope, and that does not really necessarily, even if you study mechanical engineering, or you study, you do a research in energy management, the moment you start engage in different activities. You just don't want to bother yourself about the research that is required for energy management. So, because you have your own job that you want to do. So if you have to now begin to use Energy Plus, then it's like, am I doing another PhD? So it makes it very difficult, for end users. So, but it's a fantastic, tools for energy management, for building system simulation, for architect can use that, researchers and all that. So, and then even utilities, they have to maybe get experts to be able to use that to analyze some data that they can use to provide some information to their client and all that. So similar others, EnerghxPlus to the UK, and then the tools for EnerMap, they have similar trends of those challenges. They are majorly targeting developers. When I use the word developers, I mean researchers, and the people that have used those tools and that will continue to use those tools, to simulate, to calibrate the system, a case that they want to calibrate, and you provide analysis and provide results, and that is all. So when you need that for another case, you have to do the same thing all over and all over again, and which very, very much laborious. And so that's exactly what's observed, that make this very much far away from the hands of the end users, so obviously they are not able to make use of the benefit of that. So let me talk about the experience I've had, trying to do thermal comfort analysis myself in my research group. So now we're talking about thermal comfort analysis. When I started at the University of Lagos, I picked a building envelope particularly. Those that are familiar with University of Lagos will know university cafeteria, as they call it, 2001. So one of the students, drafted that schematics of that very building envelope, and then we did a study, and that obviously was published in that paper that you can see, a modified a PMV model for indoor thermal comfort analysis. And now what I just want to say about the analysis method is that when you have a building envelope like that, you want to understand different distribution of different field within that very building envelope, and then you have to use tools. I call them flow solver, and that with that tools you will then be able to solve, whether it's temperature field, whether it's concentration field, whether it's the velocity field. There are different solver that people are used to. We call it, computational fluid dynamics, and they are far away. The commercial tools, they are far away from you. For example, whether it's Fluent or you just have an interface and then you put some information. You have no control over how to make changes about, what is going on within that building envelope, which we call solution domain. And then you want to make some changes in terms of reactions and all that. So oftentimes analysis becomes very difficult. So, but in the research group, I've had different set of flow solver that have developed, even before I started practice. And this flow solver I have to give to my student to do the research. So they would need to spend time to then model the physics and whether the thermodynamics that embodied what they want to study. And I must tell you, it is not easy to do that. It's always very, very time consuming exercise. That's what they call setting up that. So my students don't use commercial code because of the limitation I just mentioned. But to use an open code that I've listed like that, you can see 2D FVM, you see 3D, you see LCM, that's finite element method, and then you see, quadratic, also finite element method, those, among all that, these are all three-dimensional code. The first one that I listed here is the two. That's the easiest one, and that's the only one that I've already been given to those. Most of the students, very few students have ever worked on the three, just to reduce the complexity and the time. So, and what are we doing when in any code, in any problem, we are just solving equations, depending on the type of problem we are solving. The file that you see there can be temperature, it can be concentration, it can be velocities, and once you have those very model, then you have to do what we call discretization, and then before you can then begin to stamp that on the code that you have set up. And keep in mind, I'm talking about a code that you will spend a longer time for you to even set up before you now start stamping, the problem, the mathematical, discrete mathematical on that very model. So I've had a situation where a student that chose not to work close with me in terms of supervision spent a whole year trying to set up a code and could not even set it up. So I began to think, this is not a sustainable way of doing research. If, as long as I love people to have access to the code and be able to model the problem, still this is time consuming. So that's a challenge that I just want us to understand. Another student I worked, as you see here, still use the 2D final thermal comfort model, spend time on his own. Every student would have to first of all start by setting up a code, and validate it before you start talking about how to use the code to solve a particular problem. This particular student, is a master student and was able to do that. And I saw a problem that has to do with understanding the influence of the insulation thickness of the building envelope on thermal comfort, and the different space where the occupant, position they stay, and all that. So that is all that are different, just case study of what a building level can give to you. So let's move to what we call net zero energy management. So what are the sustainability issues with that? Now, for us to really understand what net zero energy management, you need to just look at these simple equations that gives an index, and the index is to vary between -1 and 1, and that is just to find exactly the difference between demand and supply. Demand here is the energy demand of a building envelope. When you do energy audit and you are able to estimate that, and the supply now is talking about the renewable energy supply that you integrate to that building envelope. So if you are able to ensure that the demand equal the supply, then you say that building is independent. So that's called what we call net zero, energy. So what we talk about net zero energy management, what we aim to is to manage a building towards reaching this zero. So as you optimize every activity we do in a building, you're trying to move that very building, to, if you are from the index 1, it's completely depend on the grid. You want to move to zero, and then if you go to minus, that means you are basically supplying to the grid, so that's the logic here. But how do we ensures this? Keep in mind all that I've mentioned to you that are all required. The analysis and practice shows that we need to be able to manage what the energy commodity distributions. There has different field about energy system development. There are other fields about energy building services. All these different fields conventionally are all kind of independent, and that's what makes it very difficult for any any home users, a manager will be in envelope to be able to navigate this sustainability because they are all different fields. And for you to bring, the expert or people that are interested in helping you with commodity distributions, that is, knowing how much energy you use, whether it's natural gas, whether it's electricity, bringing the system developers together, that is the people that are researchers that can use the tools and give you models and do the design for you. And then the people that are just to integrate, they are installers. They have to bring those types. So it becomes very, very, tough. So one of the issues that you see there is monitoring, managing, and designing the consumption of electricity and natural gas is very, very hard. There is problem with onboarding the energy developers, on the consumer's dashboard. For energy management, there's a problem with onboarding of the servers on the energy consumers dashboard for implementation of any recommended energy efficiency services. And also there's the designing of the renewable energy system that is supposed to be used by the end users, so that you have that energy potentials and do analysis that I've talked about, thermal comfort and indoor air quality analysis. Those are all the challenges. And then calculating the end users, zero emission ratio on the assumption of being able, the adoption of being able to bring electric vehicles, and then be able to assess all the various indices to like affordability, the accessibility, and the availability of energy. So until we are able to do all these, then we won't be able to have this sustainable energy transition that we are aiming at. So those are the issues that led to all that have observed over the past few years that have been navigating the regulated energy market. I must say that quickly, I started this, learning about this when I stepped out of the research lab in 2008, and I have to study the electricity market, and study natural gas market, and work with the end users, understand their problems, and that led to the model that we are presenting now, the Foundation for EnerghxPlus, and which was submitted as a patent in 2010, to the Canadian Intellectual Property Office. And so as we speak, with all these problems, and it's a platform that is now ready to be launched, that we will test run it, in the different jurisdictions, including Nigeria, Canada, and the USA. So this is called EnerghxPlus. EnerghxPlus is aimed to actually demystify brain drain, with research mobilization. I can tell you that platform, as we speak, just in June, has been patented by the USPTO. And as you can see, sorry about that. That platform can do the energy audit, and the commodity management, can do the renewable energy conversion and sizing, can do EV charging infrastructures, can accommodate building HVAC modeling, and then provide a digital solution that will solve that, by really bringing that energy consumer together with developers and the server on the same platform together. So that is the novelty of the platform. And the architecture of the platform is clear, as you will see, can deal with this different type of any type of building envelope that you we've talked about. And the handshake, as I've mentioned, is just bringing these three different type of users together on the same the same platform to provide a single solution. And they'll start with the energy audit, move to net zero, and then the last stage about the heat and mass balance simulation. I can show you the very first stage of it, which is the basic flow plan. It looks like this, and as you can see that as you speak, you and the the users on this consumer basic flow can access the building, to use the building information to get your building data, and then from there you come here and then do the sizing of the solar energy potential of that very building envelope. And the moment you've done that, you do that potential for wind energy, potential for the building envelope, and then you do the biomass as well to get the potential for the building envelope. And then you come and you do the analysis, and you do all these, for the basic flow with, free of charge, no obligations, and you have the privilege of then understanding exactly what you need to do for your building envelope. And once you know what you need to do for your building envelope, then you can then begin to move to assess the service provider, whether developer or servers that can actually provide those services to you. And then from there, they can get to walk you through the report that you have gotten, and then you can choose afterwards to then upgrade your plan. When you upgrade to the standard, then you would then be able to move forward with whatever you want to do. Let me go back to the slide, and so that I can move forward, so we don't waste the time. Give me a few minutes here. Okay. So that's the basic plan that we just, so let's just move to the next one. There's a standard plan. I can open that one as well. The standard plan is almost, that's after your upgrade, and then from there you can actually access, set up your commodity, whether it's, in terms of electricity and natural gas that you're using, if you have, and then you can then do various things, like, okay, here you have do the zero emission vehicles for analysis, and then you can do the net zero energy building for that, and then you can do the thermal comfort simulations. I've spoken thermal comfort analysis here, before conventionally. Now you don't need to access, you don't need to set up any code. You just need to put simple information, and then you run the code. You can see the code here. You can have access to the server for finite volume. You can have access, to the server for finite element, and then you can do the simulation in 2D. You can do in 3D, and so that what EnerghxPlus allows you to do. And once all that is done, then you can then move, to the energy services engineering services you want, different type of services, including the solar energy system, designed. Wind energy system can be designed. Biomass energy system can be designed. You can do building, HVAC modeling. You can do battery storage. You can do EV charging infrastructures, and all that is possible. And then from what that is done, then you can look at reviewed what you have gotten, and then you want to start a project, you can then submit it, and from the back end, they take it off from there, look at all that you had, and then you move forward. So that is just because of our time, what I can share for now, just for you to see what we have for the standard flow plan. And from there, I think maybe more information can come, from questions. Sorry, I actually want to move to the next slide. Yes, so that's better testing strategy. So the strategy is, like I mentioned, the platform will be available in Nigeria, Canada, and the US, and then we have residential consumers that will be selected for beta testing, just to test the accuracy, the user friendliness, and everything that I've shared with you on the very slide. They can use it with their various video envelope free of charge, and they can let us know exactly how that feels. And we'll have different sets of commercial consumers, and we have servers, and we have developers, and all that. So those are what we hope that we're going to do in the next couple of weeks. Hopefully before the end of this month, we can that can start as we speak. So that's where we are, and that is what I called thermal comfort and net zero energy analysis made easy with EnerghxPlus. Thank you very much. I would open the floor for questions so that we can move forward. Thank you.
Thank you very, very, very much, sir. Thank you very much for taking us through such wonderful presentation. We are indeed delighted. Now, we'll be moving to the questions part of this webinar. So if you have any question, you can do well to raise up your hand in by reacting on the on the webinar. If you are still wondering what the webinar is all about, actually, it's just a way to put energy management in the hands of what consumer, right? It's a way to put energy management in the hands of what of consumer. It's a way to help researchers. It's a way to help both energy artisans also make their work easy, right? It's a way to help researchers optimize their duty. It's it's a resource that help both the consumer and what manufacturer. That's what EnerGX Plus is all about. It's a wonderful, well thought through tool for everyone using energy. And that's as much as you're on it, we are all what energy users. So, like we said, this is a part where we get to ask questions. So, if there's any part of the discussion that might have been um blurry to you, or if there's any part of the discussion you'd like clarification on, this is part time you have to ask your question. If you're an energy artisan and you want to ask whether we've got something for you on EnerghxPlus, Plus, this is the time for you to ask the question. So we are open to get questions from you now. Any question, let's kindly react and we'll give you the floor. Thank you. Okay, so while we are with questions from our audience, I would like to ask a question from my own particular end, right? Two is a wonderful one, and that I'm more positive about is the challenge that it poses, right? Like we all would agree, globally, we have more poverty ratio when compared to the rich, right? So most often, when I mean the like people that are their income is actually below average, they don't most likely always care about their energy consumption, nor do they see the need to even like check out the amount of energy they are consuming. They are not even concerned about any alternate route of sourcing energy whatsoever. So my question is, how does Energex Plus solves this dilemma? How does Energex Plus prove its importance to this set of people, because they are actually the majority? How does Energex Plus help this particular set of people? Say, for example, a farmer in Osun State or Ogun State, puzzled about water production to what do I call it, to wet his farm, and electricity to keep his refrigerator storage running, and all of those things, but he's so unsure. He does not even know anything. Like, how does EnerGX Plus communicate importance to these people, and how does EnerGX Plus ensure that this set of people, they are catered for? That's my question particularly. Yes, sir.
Okay. Okay. Thank you very much. Let me start by saying the experience that I had, like I mentioned, in 2008, when I stepped out actually of research scientist in the government lab, to start this very business. I was doing energy audit alongside selling electricity and natural gas for another company that that sells these products, uh, uh, to end users in the province of Ontario here, and then we go everywhere, all across different cities in Ontario. Now we can travel, and then we get them to get enrolled. And why are they enrolling? Instead of just leaving themselves with whatever their utilities, their bills give to them, they are getting enrolled because of the incentives. The incentives is that, the cost of electricity and cost of natural gas always fluctuate, and they want peace of mind, and they don't want to, like, the prices has changed, last month is different from this month, and then even it can change every day, so they just want to, like, have a budget. If, like you've mentioned, someone that is having a farm, he knows how much it's making, and the average, so if I know my energy bill is fixed at this particular time, no surprise. And for those people, they just will enroll with those service provider. And I was doing all that with them, and in my head, I was like, if I want to get into providing a solution that is driven not by financial calculation of the market price of energy, but by helping them to use less energy. That's where energy management comes in. It still comes down to paying less. There's nobody that is not interested about paying less money for energy that he or she uses. So I'm talking about in North America, where electricity and natural gas are all in abundance. They are all, the concern is that, how do I reduce my energy bill? It is not a different story for Africa. Africa, the electricity is not very much in abundance, but it's still very costly. Because of it not being in abundance means that they have to go, produce that electricity by themselves, buy diesel, getting that. All the cost of doing that is very much higher. Most of them are closing business because of that. They are leaving their business because the cost of energy is much. So there's no one you will go to and say, this, here comes a platform. All they just need to go through is just go through the rigor of, first of all, helping you to set up your historical, uh, the historical data about your energy usage for your billing envelope, just once and for all on this very platform. Once that is completed, you can do it yourself. An associate of Energex can also assist you. You do that free of charge. And at the end of the day, that helps you to, like, oh, no, if I do ABC, I will be able to reduce the amount of energy that I am using. And if I use the amount of energy I'm using, I'm paying less. Definitely that is going to lead to what? Interest. So that's how the same equation from jurisdiction to jurisdiction is all about paying less by using the platform free of charge. I hope that answered the question.
Yes, sir. Thank you very, very much, sir. Thank you for that response. So from the response, I'm able to get that is a way to mitigate energy cost surprises and allows well thought, like allows budgets in place of energy. So that's actually a good incentive to end users. Actually, it's a good incentive to end user. And if you've been following us, you'd also know that on EnergyX Plus platform, you have access to what artisans, energy artisans that you can easily call up their what for their call them up on their what on their skill so they can help you put some things in place. So I believe now we should have questions. All right, so Sir Kendi Olaiton, you can go on to ask your questions, sir. Thank you.
Good afternoon.
Yes, good afternoon.
Yes, sir. Yeah, I haven't listened to the lecture. I have tried to comprehend what the system is all about. I want to ask that, is there a way this can be commercialized into the Nigerian system? Because things like this, sincerely, are strange in the Nigerian environment. But what can we do? How can we ensure that this can also be like, for example, we have some industries in Nigeria. that use both solar and electricity. Is there a way we can sell this thing to them and let them see the importance of having this kind of system embedded in their process?
Okay. Thank you very much. That's a very wonderful question, and the beta testing slide, I still have it on. You'll see that we have a plan to getting this different set of people, consumer, developer, and servers. I didn't go so much into more because of our time, but because of these very questions I mentioned, we're starting with focusing mainly on the developers and servers. So across, since you're interested in Nigeria, so that means prospective developers and servers in Nigeria are welcome, uh, to enroll for a training. So there will be a training that will be launched immediately this platform becomes available. As we speak now, everything that I've shown you in this presentation is still on the test platform of the server. So, but once that is completed, maybe in a couple of 1 or 2 weeks, we will look at whether the beta testing can start. So that testing then means that it will now be open. But we would want to, all consumer can use it anywhere. We don't need to monitor consumers are using, but we will be focusing on those that we particularly identify as being part of the beta testing, across these, 3 jurisdictions. But your interest is in Nigeria. So for Nigeria, those will monitor. So their interest is just for them to let us know what their feedbacks are. So that's for consumer. But for developers, those that are interested now, servers and developers, they want to be an associate of EnerghxPlus, right? It means that they will now have to do training. The platform has a training package that comes with it. That's not part of the presentation today. So that training, which is more like those that are familiar with LMS, learning module systems, they can asynchronously access all the materials aligned with their discipline and then be able to pass. So once they are able to pass, then they can become certified associate of EnerghxPlus. Those are going to be members of the technical team that will now begin to provide services to consumers. So that is the way EnerghxPlus is patented to operate. That is a unique novelty, of the patent of EnerghxPlus. So the training is part of that, So and with that, we will be able to have the platform accessible to this different set of end users. Now, you mentioned industry. I need to warn. The platform presently does not target industry. It's targeting for a launch. Industry is still part of the plan. But for now, when we're talking about building envelope, we are just talking about commercial building and residential building. So commercial building can include farm, right? I want to isolate industry because there are different dynamics that has to do with some machineries, and so those cannot just be audited only by just looking at the nameplate and putting the boilers and so those are heavy machinery. There are different, high level of analysis that are required in modeling those big machineries, So that's why we presently limit the capability of EnerghxPlus to just residential and commercial end users. Does that answer your question?
Absolutely, sir. Thank you very much, sir.
You're welcome.
All right. Thank you very much, Sakende, for that wonderful question. So if you still have any more question in the audience, you can kindly react, and then we'll give you the floor to ask your question. We'll give you the floor to ask your question. So I'm just going to wait about 30 seconds to see if any hand will be raised before we move on. And we're getting close to the closing of the session. So if you have any question, this is the right time to ask.
Okay, so I think in the absence of question for now, let me just, because of our time, let me just, as usual, every week, you know, when we have the live webinar, we have the opportunity of knowing what is coming next week. So this week is not an exception. So next week, as this a new series starts today with the energy management. Efforts are being made to have a lineup of experts in the field of energy management come make presentation. And next week already, we have Professor A.S. Sambo. Is a very well-known international speaker. He's a founding, Director of Energy Commission of Nigeria, and he's well pleased, to be our speaker for next week. I just want to look at this topic quickly. His topic will be on sustainable development of electric vehicles in Nigeria. And we want to speak about charging stations, research, development, and the way forward in a situation of electricity inadequacy. So that will be our speaker for next week. We'll be very, very much delighted to have him around and then to really come and open the floor for us. And then after that, we'll have different other experts across the globe, coming to speak on in this very series. And also, I want to particularly mention a change in the timing that this webinar will be taken off. From next week, we'll be starting in Nigerian time by 3 p.m. So we move it forward by 1 hour. And this is particularly based on feedback that have just reached me. I know we have been concerned that, we know 2 p.m. a lot of people are working, particularly in Nigeria. You are still at work, you have not closed, and all that, so you can catch up on YouTube because of that peculiarity. So that's what we just been looking at. But a feedback that came up just mentioned, like a Muslim audience that needs to go for Jumat, that is not convenient for them. And I just responded back to the audience that members of the Smart Organizing Committee, we have two dedicated Muslims, and they all agree to the 2 p.m. And they told me it has to come from outside before just alerting me that no, 2 p.m. is not convenient. I was like, wow, and these people did not tell me, but anyway, that is what led to the change. I know we have other activities immediately after this seminar. We're supposed to have started by now, and then maybe they are looking at to round up that activity, so it's better for us to start earlier. But all the same, for most of the outsiders, we want to ensure that the time we are starting the live webinar does not inconvenience their Jumat service. So that is the change. So from next week, we'll be starting by 3 p.m. So thank you very much. So I think in the absence of any other questions, because of other activities, the moderator can round up. I just want to appreciate everybody for the presentation. I mean, the attendance and participation and consistency in coming, to this weekly live webinar.
All right, sir. Thank you very, very much also for the wonderful presentation. And thank you very much to our wonderful listener who has always deemed it fit to be with us week in, week out. We really appreciate. So by God's grace, next week we'll be having Dr. Zambo here, Professor Zambo here with us, with another wonderful topic, still in line with what's energy management series. So we hope to see you all next week, Friday from 3 p.m., like Dr. have said. Thank you, sir. And
3
thank you to
p.m.
every one of us. 3 p.m. Yes, sir, 3 p.m. And thank you to every one of us. So do have a wonderful rest of your day and a great weekend ahead. God bless us.
Bye bye.